What is up, beautiful people? Today we are doing AP Calculus AB free response question number 5 from the 2013 test on area and volume. Let's get started. So it says let f of x equal 2x squared minus 6x plus 4 and g of x equal 4 times the cosine of 1/4 pi to the x. Let R be the region bounded by the graphs of f and g as shown in the figure above, or in my case to the right. Find the area of R for number A. So, okay, I want to point out here that g of x is a cosine function, which kind of resembles this curve right here. This is our g of x. Looks like a cosine function. That's how I tell them apart. And this bottom curve here then must be f of x, but it also looks like an x squared function. So x squared and cosine. Alright, cool. Okay, so for area, the area between a curve and the x-axis is always some type of integral. That's just what integrals are, area. If it was just g of x and the x-axis, I could take a basic integral. But it's between g of x and f of x. So I guess I'm just going to be subtracting f of x's area relative to the x-axis from g of x's, and I'm going to get r, this remainder right here. Cool. So let's do it. So we're going to be taking this integral, and our limits are going to be from 0 to 2. Thankfully, they gave me the points of intersection that I needed. So from 0 to 2 of this top curve, g of x minus f of x. Alright, so this is going to be difficult, especially by hand. It's a lot of antiderivatives to look into. So I'm going to start with the antiderivative of g of x. So g of x is equal to 4 times the cosine of 1/4 pi x. This kind of looks like a u substitution problem, so that's what I'm going to do. I'm going to make u equal to 1/4 pi x, meaning that du is going to be equal to just 1/4 pi, and to get rid of the 1/4 pi when we're substituting it in, I'm going to be multiplying by 4 over pi. So my final, then I'm putting it back into the 4 cosine of u du this time. Taking the antiderivative, I have 4 sine u, which I then substitute u back in, and now I have 4 sine pi over 4 x, that's a messed up looking x, times 4 over pi. Great, so that's our g of x. Now we want to subtract our f of x. And our x, we're just going to be taking the antiderivative of 2x squared minus 6x plus 4 dx. This is a pretty standard antiderivative. It's just going to be 2/3 x cubed, because you remember we're adding 1 on to the exponent and figuring out what our new constant's going to be, minus 3x squared plus 4x from 0 to 2. Because I'm lazy, I'm just basically going to be plugging in my values here to actually find my area, because I don't have to simplify it on the AP free response. And I'm not going to forget B minus A, the first fundamental theorem of calculus. So my final answer is 4 times 4 over pi sine of pi over 4 times 2, which would be my B, which is my 2 plugged in there, minus the 0, and if I just evaluate, that's just 0, so that's nothing. So minus our f of x, which is just 2/3 2 cubed minus 3 times 2 squared plus 4 times 2. Haha, AP graders. And again, the 0 just turns out to be 0, so I don't have to worry that. It's my B minus A. Alright. Part B. Write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 4. Woohoo! My favorite. Do not evaluate, but just write it. I love it. So for the sake of this, I'm going to just draw my line at y equals 4. So once again, to find the volume, I'm going to need an integral of some sort. But instead of the distance relative to the x-axis, it's this distance between y over 4 and our curves here. 1, 2. Cool, which is just going to be 4 minus f of x or 4 minus g of x. Actually, we're going to incorporate both. I want you to notice a gap here between region R and our line y equals 4, which means that we're going to have to do a washer method problem. So I'm just going to sketch out a nice little circle here. So this is my big radius, this is my little radius. So you'll note that my big radius is the distance between y equals 4 and my bottom curve, which is f of x. So 4 minus f of x. And then this little radius right here is 4 minus g of x. Alright, awesome. And we know that the area of a circle is just going to be pi r squared, but because we have this little circle being subtracted from the big circle, we're going to have to subtract the other one, pi r squared. Alright, so then if we set it up, it's just going to be from 0 to 2 again. These are my points of intersection. I'm going to pull the pi out of here of pi times 4 minus f of x squared minus 4 minus g of x squared dx. Do I have to substitute in what f of x and g of x is? Probably. Mr. Duham, just pretend that I actually did that because I'm lazy, like I said. Great, moving on to part C. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Write, but do not evaluate, an integral expression that gives the volume of the solid. Cool. So each cross-section perpendicular to the x-axis is a square. So that's just this distance here, whatever that might be. I'm going to set up a little square to kind of visualize what that area would be. And this is our base here, which is just really g of x minus f of x. And the area of a square is just side length squared, so we're going to square this. And that's our area. Now I can set up my integral, so that'll be from 0 to 2 of g of x minus f of x squared dx